Okay, I realized there was one last part that I did not teach you that will be on the test. Um, and you can roll your eyes, but um, it's not that big of a deal. So what I'm going to do, I'm going to move the test to Wednesday. So today we'll review this part called dilutions. Um, and then I'll have Heather show a video and then pass out a worksheet that you'll start today and work on tomorrow. And then tomorrow you'll have the class time to watch the videos like I was going to have you do today. So remember tomorrow to bring your headphones so you can go over the videos that might help you with any of the problems that you miss. All right, so first off, this is towards the end of your lab book. I don't have a lab book in front of me. Probably page 17 or 18, I would bet. Probably 17. Um, and we're talking about the idea of dilutions. And dilutions are honestly not that hard to figure out. So what I have right here is a picture of a beaker that has copper 2 sulfate in it. And let's just pretend, and it doesn't matter, but let's pretend the concentration of this is 1.0 molar. Um, but that's more concentrated than I need. So let's say I want to make it 0.5 molar solution. It doesn't take long to realize that this is 1/2 of that. So all I would do is I would take my beaker of water and I would add water and double this volume. And I can't really see that. It looks like, man, I can't even guess on my screen. Probably, let's just say it's 50 milliliters right now. So if I add 50 more milliliters of water, I have diluted it or made it half as concentrated as it was before. All right. Now, that is simply what a dilution is. You have made a dilution before. You put your one little blob of orange juice out of your frozen can in here, and then you add 4 more cans of water to it. So you have taken orange juice concentrate and diluted it with water. All right, now think about this. The amount of orange juice concentrate present hasn't changed. We have just diluted it so that it's in more water. Just like the amount of moles of copper 2 sulfate here has been held constant, its molarity has changed because I've changed the volume. And molarity is moles per liter. So this will stay constant, but this changes, so that's why these numbers change. Now let's fill in some blanks real fast. A useful laboratory technique is to make concentrated solutions and then dilute them with water to make less concentrated solutions than you need. The more concentrated solution is called a stock, S-T-O-C-K, solution. All right. So when I purchase acid for this class, um, like hydrochloric acid, I purchase it as 12 molar. But I would never let you guys use 12 molar because it's extremely dangerous. It burns on contact. Just breathing the fumes can burn your lungs, cause you to get very sick. So for most laboratory experiments, we use 1 molar. So in order to make 1 molar from 12 molar, I dilute it um, with water. All right, so typically, since this is so dangerous, I'll first dilute it and cut it in half. So I will make it become 6 molar right off the top, so it's a little bit safer for me to deal with. All right, so I have a bottle of 6 molar. The way I do that is I just add equal parts water and equal parts acid. Then I actually do that again and take it to 3 molar. Um, so now it's equal part acid and equal part water. And then from there, usually I'll go to 1 molar. So I will dilute it now with 2 parts of water and 1 part of acid. So I've done a series of dilutions to make this less dangerous. All right, now there's an easier way mathematically to do that, and it follows this idea, which might look very complicated at first, but I promise you this one will boil down simply. So we're going to take advantage of the fact that in a dilution, our moles stays constant. So the equation says that the volume, and remember, let's say volume is in liters, liters times concentration, which is molarity. So I'm going to write that what it really is, moles per liter, is equal. So when it's concentrated, that's this side. When it's diluted, that's this side. All right, I have my liters again for volume, and I have my moles per liter for concentration. Whoops, T-E-R, a little dyslexia got me there. All right, so what happens is the unit of liters would cancel out, and I'm left with my moles equaling my moles, which is what I said a few minutes ago, that the amount of moles in something stays constant. Um, it doesn't matter if you add water, the amount of moles are there. All right, so the way that this would boil down mathematically can be shown here. It says what volume of 1.5 molar sodium nitrate, so that's going to be a number that we need, solution can you use to make 200 milliliters of a 0.5 molar solution? All right, so we're looking for the volume of our concentrated solution. We know its molarity. We know the volume and molarity after. So now we just would simply take this number over and put it underneath, as you can see here. And then we can see the answer is 66.6. That's a coincidence. Chemistry is not of the devil, I promise. All right, if you will look, I'm going to erase all of this. If you would look, this thing breaks down, and it does this every single time, into these 3 numbers. And you have 200 milliliters, and it was right there. You have 0.5 molar, it was right there. And then you have 1.5 molar, and it came from over here. The way I like to describe this, if you'll look, this number is all alone. So I call this the loner. You will notice these two are close, so I call them the pair. The pair are connected by the word of. All right? So I have a little saying to help you remember how to do dilution math. And that is that it will always be that you multiply the pair and divide by the loner. And then remember, the pair will be connected by the word of. So you can actually very seriously underthink these and be fine. You just have to identify, hey, this number's alone. These 2 numbers are paired. So I'm going to multiply them and then divide that by this value. So let's look at the 2 down here. So just lower on your page. I want the substitute to go ahead and pause this for a second and see if you can do both of these problems. Remember, multiply the pair and divide by the loner. All right, now that you've had some time, let's see how you did on this. So simply we have to find the pair which is connected by the word of. It would be these 2 numbers. So I'm going to change that to a multiplication sign. And then I'm going to divide by the one that is not a pair. So 10.19 times 8 divided by 1.5. I do some math and I get 54.35, I believe, milliliters. All right, that would be my answer. Now, a common question is if I have to convert milliliters to liters, since I'm talking about molarity. The answer is no, most of the time you do not, um, because molarity will cancel out in this reaction, so you're just left with milliliters, which is fine. Just make sure you write the answer is milliliters. Now, when you do have to convert is if I give you a problem, which I will in a second, that has one listed as liters and one listed as milliliters. In that instance, it's important that you convert one way or the other. All right, so number two, these two were connected. So I have 2 times 0.15, and I'm going to divide that by the one that's alone, 8.75, and I end up with 0.034 as my answer. But since this is liter, this time I put the unit as liters, not milliliters. Up top, the unit it gave me right here was milliliters, so that's why that was that. Okay, now turn to the very back page, and you have 5 questions, I believe. Yeah, 5 questions on dilutions. I want the substitute to pause this for about the next 7, 8, 9 minutes while you work through those, and then um, we'll go over them. So do it how I usually do it. You do your math, then you compare with your lab partner. If you match, you're most likely right. If you don't, figure out what went wrong and fix it, and then we'll go over these. All right, so hopefully this went pretty good. Um, you find the ones connected by of. So you have 500 times 1, and you divide it by 10. That equals 50. Now the unit is the one that was not in there twice, so molarity cancels out. Milliliters is the one you're left with, so the answer is milliliter. Now take a second and notice what this says. It says, how would you prepare each of the following dilute solutions from the concentrated solution? So what this is really saying, and the answer would be that you need to add 50 milliliters of this to that. Now, I don't really care if you write the sentences, but that's how you would really answer this. Okay, this one, the pair is right here, 250 times 4.8, and I divide that by 15, and I'm hoping that that was 80. I did these pretty quick. All right. Once again, I chose milliliters as my unit because capital M canceled out both times, or there was 2, so they canceled out and left me with the unit of milliliters. All right, 63. You have of here, so 25 times 2 over 1.5. Uh-oh. Nope, I have it. Never mind. It is 33.3 repeating, and the unit, once again, is milliliters, moles. You have 2 of them, so they cancel out. All right, now we have these connected by the word of. So 2.6 times 2, my one all the way over here by itself is 12. And I'm hoping I did these right. And I get the answer of 0.43. And since this is a liter, the answer is liter because moles cancel out. Okay, 65 is the only one where you have to convert. It says, what is the molarity? And it gives you milliliters and it gives you liters. Since molarity is in moles per liter, I'm going to change this number to 0.750 liters. And it is the one connected by of, you will notice. So I have 0.75 times 4 over 1.3, and that answer is 2.3. And it asks for molarity, so it's capital M. Or also the liters this time both cancel out and you were left with M. Okay, hopefully you were all right with that. Um, Not the hardest ones that we do, but there is one or two on the test. I think it's two. And one of them's tricky. I'm going to tell you right now, you're going to do the math and the answer will be 1. And it's going to be like A is 1, B is 50, I don't know, C is 1,000. All right. And there's another D, whatever, who cares? Let's say 77. Your calculator will tell you 1. So the overwhelming majority of kids bubble that the answer is 1. But your answer is going to actually be telling you 1 liter, and the problem asks for milliliters, so your answer is 1,000, if I remember right. Now, I got to be careful. I didn't look at the test. Your answer might tell you 1,000 milliliters, and it asks for liter, and then the answer is 1. So read it careful, but don't fall for that. I'm pretty sure um, it's the first way. But just read it careful and make sure you understand what you're doing, and you'll be fine.